Thank you, and that's a long introduction. I was actually here at the 40th Congress, so it's been 9 years since the last time, but it's a pleasure to be back. And I want to talk about a topic that's actually something new thinking about within the industry, not just within the US, but really around the world. And it's how we bring in the idea of resilience. We understand what resilience is at that point. So I want to go through the topic of how we could fit in efficiency, sustainability, and smart systems build that into resilience within the built environment. So first thing we need to do is define what we mean by resilience. And there's different ways to look at this, but I found this from the Rockefeller Foundation in the US has been sponsoring a program for the 100 resilient cities around the world. And they look at the definition of resilience as the capacity of people, individuals, buildings, communities, institutions, no matter, to survive chronic stresses or acute shocks. And I will go through a definition of the difference between what chronic and acute would be. So if we define chronic, in the sense, that's a long-term experience. So in people, is like diabetes or heart disease. When you have that, that's chronic, that's with you for the rest of your life, for the most part. In cities, we define chronic problems as public transportation, air pollution, water shortages, energy shortages, things like that. And within the buildings, the built environment, we have chronic problems within buildings. Poorly controlled HVAC systems, bad air quality, air infiltration, how the air is distributed within that. It's inherent in the design, so that's there for the long term. Now if you look at a difference, compare that to acute. Acute are things that happen suddenly in a short time period. So in a person, an acute problem would be a heart attack or stroke, some major event that comes on. In the city, that would be an extreme weather event. And in a building, we could have a component failure in the HVAC system, or the electrical power grid goes down to whatever reason, something happens right there. Now if you look at from the aspect of this, the cities and the buildings are interrelated. It's what we call the built environment. And building does not operate only on itself, but is dependent upon the city and the infrastructure that's related to this point. So if you look at some examples from a chronic, the situation of water, maybe you've heard, Cape Town, South Africa, in the past year or two, has gone through major problems. In fact, they were to the point where they're almost totally running out of water. During this past year or so, they've been rationing water. People would go and line up and actually just collect water so they could take home the little bit that we give them every day. So that's something that we would need to plan for within our city structures and our built environment. It's something that's happening at that point. And then acute problems happen, things that happen suddenly that we do not anticipate. And on the left hand, in the United States, you might have heard there has been a lot of wildfires that are causing problems there. Actually, entire cities just burning down. Or you have major flooding from storm events. Or here in Europe this past summer, you've had extreme drought situations in parts of Germany, where the Rhine River basically is just shrinking down. Or in the right-hand column, we had a Hurricane Sandy in New York City basically flooded part of the subway systems. So all these things happen that we may not anticipate, or they happen very suddenly, and they affect the building systems and the city systems that we are dealing with. So if we look at the idea of resilience, how this applies to buildings in the built environment. There are 4 R's that we like to use, words that we look at reflective on what happened. So we as building designers and building operators can say, well, how did this building handle a similar event in the past? When the power outage happened, what went wrong with this building? How did we were able to handle that? What can we plan for? What do we need to change to make that adaptable? And we have to be resourceful, looking at alternative water sources or alternative energy sources that might carry us through an extreme acute event. And the systems should be robust. Robust in the sense that they're thought out well designed, well constructed, and well managed, so they continue to operate even when problems come up. And in some cases, redundancy will help us toward resilience. Redundant in the sense you have extra capacity, spare capacity, additional systems that carry you through problems. Emergency power generators, combined heat and power systems that will allow us to generate maybe electricity to maintain critical systems within the buildings, perhaps continuing the heating process there, all within that particular building, because if something happens, we need to be able to operate and continue on. And we also need to remember the resilience, the idea, is more than just the technology to make that happen. Resilience of people and buildings and systems is more than just the technology. It's our capacity of the people to handle those functions. The society, everybody inside the building, the location of the building depends on this. So for an individual building, how resilient it will be depends upon what the building function. If we can look at, say, a hospital where you have patients that cannot move, they're sick, we have to be able to provide for them. Or if you have a small school where children there, and if you have something happen, you cannot just tell them, you need to go home. They're young kids, they have to be able that. Or at a nursing home where you have aged people, they cannot move. So the demographics of the building, the type of people that are in the building, depends or drives the functions of what we need to do in that building to make it resilient, to keep it resilient. So in our collaboration with some of the discussions with the people within ASHRAEs and my collaborator on this program, we've come up with this concept of, say, how smart systems, efficiency, and sustainability features, how they add to resilience. And so within the industry, within ASHRAE, within other organizations, REVA and others, looking at the idea of, we've had the idea of sustainability has been an important feature we talked about for 15 or 20 years. And efficiency has been around and discussed for decades. And smart has been a newer concept there. Smart building, smart grid. All those are important. But really we think about every one of those areas, if we focus on those, also help us in making our building systems resilient. So a quick summary of how we put all this together. If you look at energy and water efficiency, they help us toward the resiliency to maintain the services there. Measures that are designed for sustainability can also help short-term resilience. In particular, like for example, if we have on-site renewable energy system, it may help us maintain some minimum level of service if that building is connected there. Now we have to need to think of how that electric power system is connected with the electric grid for that building to operate there. And smart building systems, the ability to think about maintaining the controls there, they also help us get us through short-term emergency measures. And I'm going to elaborate, spend the next few minutes talking about each one of these in a little more detail. So how efficiency can help resilience. High-performance buildings should already have efficiency built in. That's good. But how that will help us in the overall resilience. So if you look at energy efficiency, if we reduce the demand on the electric power grid or reduce the demand for natural gas, that helps not just that particular building, but the entire city, the entire structure. The less demand is out there, if you have a reduced supply due to a weather event or something happening that affects the electric power grid, the less every building demands, the more likely the entire city will be able to continue to function. And also if you look at, if we have lower energy consumption, that means lower money expenditure by the building owners, means they might have more money available to invest in energy efficiency, water efficiency, and other resilient measures. And also, less energy consumption means there are less air pollution associated with the generation of that power. So there's a way we think of how efficiency, energy efficiency, impacts resilience. More specifically, in terms of the HVAC, within the inbuilt environment, within the indoor environment, we need HVAC systems now in modern buildings to keep them habitable, meaning the function, the conditions so that people can live in those. We expect that nowadays. But reducing susceptibility in the indoor environment might be in terms of designing our systems, like don't putting major equipment in a basement of a building in an area that might have flooding going on. The picture I showed earlier, that was all within downtown New York, they had lots of their buildings, their basement areas flooded. If they had key power systems there, they were disrupted for a time. And if we also have functions for like, demand control ventilation in our HVAC, it reduces the amount of ventilation needed to maintain a good environment only based on occupancy. So that reduces energy consumption and also reduces the amount of outdoor air that we're bringing in that might have to be cleaned up because it's contaminated for something from the outside. And how sustainability measures help resilience. Sustainability is the process of minimizing the building's impact on the environment. And if you think about resilience, it's just the opposite of that. It's just the reverse, managing how the environment affects the building. So in many ways, things that we would implement for improving sustainability also will improve the resilience of the building to maintain through special conditions. And so they're often aligned when they go together. So within the indoor environment, within HVAC systems, we could design for redundancy of power lines, power supply, the communication, water supply systems. Having the critical systems managing different, so they maintain through a maybe electrical power grid disruption. We also still need to remember that the buildings exist for people. So there are occupants in the building that need to be informed. If there is an event going to happen, or it has happened, what do? Should they stay here? Do they go? If it's an office building, do they need to try to go home? Can they go home? So we need to maybe look at, in terms of designing our buildings, having places where if there is a major disruption, a major event, a weather event, the power goes out, locations within the buildings where people can gather, and the term we use, shelter in place, so they can stay and maintain a livable environment rather than evacuating and maybe going home and disrupting everything else that's going on. And then the other area we get into is how smart buildings happen. Smart in the sense of, we have a better control capability that takes advantage of modern technology, modern, modeling and predictive control measures. So we have smart buildings in their equipment, we have smart grids, and in some cases microgrids, smaller grids that may be able to continue operating when the entire larger system goes down. So smart buildings and their equipment could help protect from damage, safe, or harm from an acute event, maybe a cyber attack. They can monitor the operation patterns to see if something is disruptive going on, and perhaps even continue the control and operation through cloud-based or other communications. Also, building systems can monitor and detect when something is going to happen and perhaps automatically shift into a safe operating mode. Again, we were talking about major events that happen that might happen very suddenly, sometimes very unexpected. So they have the capability of telling people, this is where you go, you stay in this safe place right here. We will maintain a good environment for you. Maybe not the entire building, but a location where people can go to in an extreme event to keep it habitable until things come back to normal. And again, these could be a weather event, it could be a terrorist event, it could be something that's happened there that maintains that. So smart buildings and their systems can help provide a sense of resiliency and redundancy to continue operations. If they can monitor, detect a problem that's occurring, perhaps there can be adjustments within the building systems to continue to operate. And again, back into within the occupants, we need to have the ability to tell the occupants what to do, but also perhaps the occupants can provide feedback to the building systems that this has gone down, this is a problem that has here, and the controls can take advantage of that automatically. Other areas that are related to this point that I don't have time to get to in this particular talk is look at the passive survivability. Within a particular building, maintaining this capacity of operation passively without necessarily input from power from external grid. And the other thing we also would think about this is the idea of the future proofing. Future proofing meaning designing for what we anticipate the world to be like in terms of the climate conditions, the temperatures, the rainfall patterns, water availability that might exist not just tomorrow, but 20, 30, 40 years into the future. Because that building that we're designing now will still be in existence then, long after many of us are beyond our career. So we need to work from that. So I thank you for your time and attention. I did my best to keep us on schedule right here. But hopefully I've brought some thinking to the process that, again, the idea of resilience is new in a sense. Many times within the industry, we haven't thought about that. But it's also very important to work from there. So thank you.